Lagrange Optimization Method. This is one of the techniques used to find the optimum point, max. For example, in a polynomial, you have this kind of function. This is max, and this is min. Okay, so that's easy, right? Is you take a derivative of function and set 0, and second derivatives is going to show whether it's min or max. Okay, it's just a 3D. So what's different? The Lagrange optimization is you have a constraint on the value of the variables x. The x can take certain value only, and it works in 3D. Let's see how it works. Find the minimax of 3D function, and the constraint is xyz. Value is constrained with this function. So we take first derivative, set 0. This is necessary condition, right? So each direction of coordinate xyz every direction should be 0. Now you have to be careful. There is a so-called saddle point. Saddle point is like it's this way, but x direction will be like that. So it's kind of mixture of min and max in the 3D. This is like a whole saddle shape. Okay, that's also show up. That satisfies the necessary condition. So this also include this point. So we have to evaluate after you get the answer. The same thing happen in polynomial. This is kind of saddle point. Its derivative is 0, but it's not min, it's not max, it's kind of between, right? So we have to pay attention to that. Now, since phi is 0, this also the necessary condition. Now you combine them together into this, so each one should be 0. That's also necessary condition. So each one is 0, 0, 0. So you put together all the necessary condition. This is a 0, and this is 0, this is 0, this is 0. So we have a 4 equation to solve for x, y, z, lambda. So we can find out x, y, z that satisfy these 4 equation is going to be the necessary condition to be min and max, right? And the lambda is just intermediate problems, the parameters. We're not really interested in lambda. Lambda is used only for solving the equation. Example here is find the shortest distance from the origin to the plane. The question it's asking is you have x, y, z, and you have some kind of plane, and distance from point to this plane. What is the shortest distance? What is this x, y, z? So to find it, this is a constraint of x, y, z, and distance is f equal x squared plus y squared plus z squared. So we use Lagrange's method. We get 2x plus lambda a equals 0, 2y plus lambda b equals 0, so and so. And you multiply x and y and z. This is just a manipulation of equation. You add them up all together, then you get this equation, you can get lambda in terms of xyz. Using that xyz, the three more equation, we can get x, y, z minimum point. Okay, so that's an example of Lagrange optimization. I hope you enjoyed listening to this. Please check out other video too, college level math and physics. If you like it, click subscribe.